What does security look like in the age of superintelligence? You're going to need to build AI into your security program as a foundational element.
Because there's one thing to like surface these problems and another thing to help them fix it. How much do you guys want to play into that?
You first need to find the issues and then help people fix them.
Don't use the same password for every single soft token. And honestly, just don't use soft tokens because there's a seed file associated with each one of them.
I feel like every week at Armadin, the coolest stories are gonna come out. Welcome to Builders, a video series from Kleiner Perkins. Each episode, Lee, Marie, and I sit down with founders and operators building the products and tools that will define the next decade of technology.
We keep it simple: fried chicken, beer, and raw, unstructured conversations with the people that we call when we're trying to figure out what's next. These are the conversations that we have behind the scenes at Kleiner Perkins, and now we're excited to share them with you.
Maybe to start, what we thought would be really fun, Lee, Marie, was just to talk about the state of security today. And I think it's changed a lot, almost more than people appreciate.
Yeah.
What is possible today with AI from the perspective of the hackers, the bad guys? What are enterprises dealing with today in terms of the sophistication of these attacks?
First off, you've seen the China report that came out about they're using AI to scale their operations. I'd love Travis to talk about that. But what we're doing, what we see a lot of clearly on the social engineering front, people are using deepfakes, they're using AI to help augment one, messaging, two, if they're a nation state and English is not their first language, they're able to make a very compelling campaign around how they can convince people to click their links or their malware or whatever, in addition to the voice replications with deepfakes and everything. So that's significantly scaled up in terms of sophistication and just very compelling campaigns. And then apart from that is going to be weaponizing scripting. So any sort of automating scripts, development for scripts, how do I scale data processing and things like that, creating exploits on the fly. We've actually been able to do that with our agent already as well. That's the barrier to entry for a sophisticated threat actor is now a little bit lower because you don't really have to be the best exploit developer to now use AI to create an exploit. So that's a little bit scary in terms of the capabilities when it comes to exploit development and creating code on the fly with vibe coding and stuff like that. So that's definitely already on the table. And so in addition to that, you can kind of build attack paths too. One of the things that our agents does as well, that we've seen research already done in addition to what we've already done, is building out attack paths from, for example, if you have one user account, pre-trained models, in addition to some fine tuning, you can say, hey, what's the blast radius of this one account in an Active Directory environment? How far can I go? Are there vulnerable Active Directory certificate template services that I can leverage with this one standard account? And it will actually go through an ADCS ESC1 attack, for example, which is a common attack in Active Directory on escalating privileges. And it will orchestrate the entire thing for you. Is it perfect? No. We can make it perfect, but out of the box it's not, but it'll still do it. And it's relentless. It will not stop until it accomplishes that mission. It may get a few things wrong here and there, but it knows, the pre-trained models know how to do that actual attack. And so it's a little bit scary, and you can take, like I said, kind of an entry-level person and scale them up a little bit now, because a lot of these models know how to do some of these attacks if you know how to tell it and prompt it what to do. We'd love to hear your thoughts on what the Chinese are doing in other nation states as well.
Yeah, I think organizations have never been less secure than they are today, right? And I think we exist in a time of kind of two overhangs, right? On one hand, you have AI attackers, right, or threat actors that are now empowered through the use of AI. The GTG threat actor in China, others who are developing similar technologies, where it's now making it so it's much more feasible to create new and novel attacks. New and novel is becoming the new normal, where it used to be you would have global 0 days. Now it's individualized 0 days in an environment that are easier to develop than ever before. And the second overhang is the attack surface from AI applications themselves, right? Usually in a technology wave, you kind of deal with either an acceleration of the attackers or you deal with an expansion of the attack surface. What we're living through today is both happening at the same time simultaneously, and the capabilities of the attackers increasing rapidly while the threat surface increases rapidly as well, right? And I think this is really creating a moment where organizations need to fundamentally rethink how they do and architect their security. They need to be rethinking it from a lens of offensive or proactive security first to guide and shape their defenses, as they need to reimagine and re-architect their defenses. They need to approach things from a governance lens, and for many organizations that's very challenging because they've sprawled out as an organization, they've gone and done lots of different things, and governance is usually about re-architecting the foundations of how you operate from an IT perspective, how you operate from a security perspective. So I think all of that is really creating this new urgency around reimagining security, reimagining what it takes to be secure, to answer the question for an organization of, am I secure? Where am I insecure? Which of these matter most to our organization and its goals?
I'm actually curious, has there been a specific incident caused by LLMs yet that you can point to and be like, that is really scary? Or you should be really scared of that incident?
Maybe to use two examples, one on the first and one on the second. On the first, as Evan said, right, being able to have agents that can go and generate exploit code on the fly, right? Be able to create new and novel attacks, from an agent in seconds that would have taken an exploit developer weeks to do in the past, right? Or months to do even against a hard target, right? That is being compressed down rapidly, and kind of the cost of exploitation is trending down to zero. So I think that absolutely on one side. And then the other side is that as agents are being deployed, these are actually fairly trivial to compromise today. To use the example of a large retailer, they moved from a kind of NLP style support chatbot to an LLM-based one. Now it's actually vulnerable to prompt injection attacks, where it will actually just refund a purchase when you ask it to, right? These are things where it's like the threat model is changed in that element, and they're rolling out things rapidly because they need to. Their business needs to keep up in the age of AI, but it creates this big exposure surface for them now that they really need to contend with.
I think also to add to that, sometimes it's hard to tell like what's being done with a human versus AI, because it can replicate a lot of what our actions are doing and it look very legitimate. So it's like, unless it's like sheer scale, like we're just throwing, 1,000 agents out, you're gonna just, from a volume and scale perspective, you're gonna know it's probably like a whole swarm of AI agents. But if it's like trying to replicate human behavior, which actually Travis built an agent that actually does that, which is pretty good, it's hard to tell, because one of the ways we used to do it in the past with automation was like maybe the user agent string is out of a bot. It's like maybe curl or something like that. So you can kind of tell what's scripted and what's not, versus like an actual Chrome user agent string that might be a human going to the website and looking at, vulnerabilities or whatever. So like, that's one of those situations where it's a little bit now difficult to tell, because we've included a lot of that. We want a normal user agent string. We created a bot that specifically does human level speed if we want to look more covert. And so it'd be hard to tell like what's a human versus an agent in some cases. But if we're just throwing the kitchen sink of, we want to, essentially unleash our entire army of agents on you, you're going to know. Like, it's just scary.
Well, what scares me a little bit, I think you said it, Travis, was like the cost of maybe not developing an exploit, but like just effectively trying to hack a system has gone down by 100x to 1,000x, in which case it becomes economic to just kind of throw the whole kitchen sink at it, to your point. If you're a CISO today of any large enterprise, like, what's your advice to them? Like, what do? You're coming to 2026, you're trying to do resource planning, figure out how to rebuff against AI. I feel like every CISO is kind of this unsung hero. You talk to him when things are going well, and the minute something doesn't, it's like his neck's on the line or her neck's on the line. Like, what's your advice to them?
Yeah, I mean, I think it is that, it used to be fine if you could cover 90% of your attack surface, right? Now you actually need like 12 nines of coverage on your attack surface. The only way you're going to be able to do that is with AI. You're not going to be able to get there with traditional methods of trying to scale humans, trying to augment. You're going to need to build AI into your security program as a foundational element. And at the same time, you're going to need to make, the hard changes to the foundations of your organization and how it operates to allow you to have better security governance. Google went on this journey and was very successful in gradually rolling out better and better security governance policies across the organization for everything from identity to application allow listing, taking the company and organization on these series of improvements. And every organization is going to need to go on that same journey.
Maybe with all this as a backdrop, what is Armadin? Why did you guys just set out to build a new startup to help companies deal with this AI threat?
At Armadin, it's fundamentally this idea of what does security look like in the age of superintelligence, right? And starting with the idea of building the ultimate attacker that can answer the question, are you secure? Here are the ways in which you're insecure, and here are the ones that matter most to your organization. So that you can have this real-time battlefield view of what does it look like to see my network through my attacker's eyes. Where are my defenses deployed? Where do they need to be deployed to be effective in securing those objectives for my organization, right? So that, going back to where we were, right, that a CISO can be able to put AI into their security team and have it deployed against the objectives that matter most for them, to be able to shape and guide and light the way for their defense where they need to be spending the most time. And that really starts with having the best in the world offense constantly pressure testing you with a swarm of AI agents trained and informed by the best hacker expertise on the planet.
I guess how general are the customer environments? Like, have you picked a particular type of customer, or how do you kind of prioritize?
Yeah, I mean, we've kind of started in a variety of industries and at the top of kind of 1A enterprise, right? I think it's, with all software projects, you kind of need to build the core engine and then adapt it to the environment you're in. And the problem is if you start by building a Honda Civic engine, then you're not going to be able to, have the Ferrari engine that is needed for the most complex environments, the most, things that are going to put you through the paces the most. And then you're going to be left to like rebuild the whole car once you get there. And so we've kind of started with the most complex, most demanding environments, because then you can go and create the integration hooks, or you can create the scalability down after that.
And like, just to kind of like put it in very simple context, like the why we got created too, is two reasons that I can think of is, one, you really need to prepare for the age of what we call hyper attacks, which is like an AI swarm that come at you, because we know nation state threat actors are going to use the same capability. But also, like, having run the red team at Mandiant my whole career, I saw towards the end of my tenure at Mandiant, I was at 13 years, we were doing human-led assessments once a year on average. People would hire us, hey, I want you to do our annual pen test, or I want you to do a covert red team. And we almost always won. And we would accomplish the objective like 90% plus time, like almost all the time.
Wow.
And so it was scary. And so we would get asked, like, why is this happening? Like, why are y'all still so successful? And like, the reason is twofold. It's one, we took the path of least resistance to accomplish that objective. So all the other paths, we don't know, because we don't have the time, and nor do we have the capacity to constantly look for every single path all the time. And then the second reason is because we're coming in once a year. Imagine if you're having a human, like a true expert, like, one of our red teamers doing this 365, 24/7, we would find every single path, any new path that got introduced over the course of a year, because you have environmental drift naturally in a 1A enterprise network, we would identify as it's getting introduced, but we just don't have the capacity. Nobody does. We don't have enough talent or expertise to constantly scale to that level. And we'd probably go crazy. I mean, can you imagine? Just like,
All hours of the day.
Yeah, there's always so many hours in a day, right? So when we met Travis, like, Travis is built to multi-billion-dollar platforms that scale to millions across the world. We know how to code, we do really well, but I've never built an enterprise-level product before. So combining true expertise with true engineering talent was like how Armadin was kind of created. Like, this problem truly existed in the industry. Like, how can we solve this? This is not good enough. Clients, we're winning still all the time. Like, how can we close the gap to where next time you do get breached, the impact is virtually nothing. Every single path has been closed out. Every identity misconfiguration has been fixed. And it's like the CISO can walk away, have his beer, and truly be relaxed at the end of the day. And that's the overall mission and goal of what we're trying to accomplish.
And I think Evan said it well that, historically the issue with red teaming and proactive security has been, if you go and do a human-led assessment, right, you might cover 1% of your attack surface and it costs you $1 million, right? And then if you want to cover 2%, it costs you another $1 million, right? And you have this linear scaling effect, so that if you want 100%, you might be spending $100 million, right? And most organizations don't have that to spend on their security budget. Versus defensive software, which tends to be, easy to deploy and to scale in enterprise, right? And so you can deploy that everywhere and get 100% coverage on defense, right? But it's not giving you the outcome that you're getting from offense, right? It's not giving you the prevention before exploitation. And with AI, fundamentally what we have the opportunity to do is to give you 100% coverage on proactive. We can cover 100% of your attack surface without costing you $100 million, right? We can have a sublinear scaling effect that puts you into a better security outcome because you're able to protect yourself before the breach, but doesn't cost you what it would ordinarily. And so really that was kind of the fundamental limitation in this market previously. And even why, with large security budgets, why it didn't really scale, because there was a huge difference between having 2% coverage and having 99 or 100% coverage from a risk perspective and what would actually be uncovered. So if you were a CISO, previously it actually wasn't very effective to deploy capital into preventive or offensive security beyond kind of what was needed for compliance or beyond kind of the crown jewels of your infrastructure. Now for the first time, we believe bringing together the best builders with the best hackers, you can create AI that can scale and create a new capability and a new kind of paradigm to operate in.
And you guys would effectively have the highest level of fidelity in turning, like, understanding an enterprise's security posture. Like, literally, like 100% of it. But I imagine this forces you to now think like a hacker. So, like, what does that look like? Like, do you need to literally take Evan's brain from Mandiant for 13 years and, like, try to infuse it into this agent? Or, like, how do you, like, go about technically building something like this?
Yeah, I mean, it really is, you basically, we think of it as building the cyber F-35, right? And you have the cockpit in the plane or the expert hacker in the plane. Yeah. And then the system is constantly learning from everything they're doing. How are they flying? What are the choices they're making? For a software engineer who's used a tool like Claude Code, right? You have option A and option B, right? You get preference pair data off of that. Once you have evaluation environments that you can create, when you have tasks that you can represent, then you can train models against those, right? We have the same for every 0 day we're able to find. We can create evaluation environments against that. We have the best hackers in the world that can train our system to generate data, to continuously train our models to make them better and better and better. The thing that I have a fun time saying is that unlike most AI companies, our customers pay us to give us high quality training data, not of their environment, but of the methods and techniques that are useful to accomplish proactive security objectives.
Yeah, because we're actually still delivering services to some of our clients, and like with my team, and the outcomes of those are being ingested into our models to learn how we were able to compromise that unique environment. Because like every environment's unique in a certain way. Up to a certain percentage, you kind of do the same thing, but then at a certain point, you have to be creative and you have to adapt to that specific environment. How did I get around like this one, pothole, or how did I get around this one stop sign, right, or whatever it may be. And you have to really be creative in your approach. To give you one example, that's actually kind of cool. One of the ways that you escalate privileges in an environment is what we call data mining. You get on a system and you get access to a wiki page or something, and you look for credentials that are stored on files, on disks, etc. We couldn't find anything anywhere. And we're like, we were kind of stuck. Like we couldn't continue escalating. So one of our guys decides to go through meeting recordings that are like an hour long every meeting. And he's like going through all these recordings manually, and eventually he finds someone whiteboard a password to a service account. And he was like, yeah, in the video. And he's like, oh my God, this is great. Let me see if that works. Sure enough, it did work. And so like that's kind of a creative, unique approach. There's no standard TTP for that. That's just being creative, right? So now we trained our agents to do the same thing. Like, you have context windows. You can have an agent specifically looking for certain files. MP4 files now can be part of our agent to like go through that way quicker than we could.
Oh, that's
across.
cool.
Yeah, so like that outcome, that methodology, having been trained from an actual engagement that we did, can now be ingested into our workflows. And so like it's delivering services and coming up with outcomes. It's going to be, our entire methodology is grounded in a certain format, a structured format that can be ingested by our agents as well. So it follows what our workflows are, in addition to a lot of fine tuning. So like the eval environments that Travis was talking about, my team actually goes in, manually assesses every single eval, and then we train the model on doing it the same way. And so like it goes through, and we have what we call these traces. I think I actually showed you one time, remember this? It was like groundbreaking whenever I first showed you. And I was like, dude, look at this, man. Like it's actually doing it the way we would do it, and like way quicker and way better, like creating exploits on the fly. Like it was awesome. But it follows our unique approach. For example, in a web app, it will fingerprint and map out the application, understand it first, so it knows what it's actually attacking, versus like, let me just throw a bunch of tools at this thing and hope something works. Like that's not how we would do it. We're very surgical, we're very unique, and we're very like custom in how we approach each thing. So we wanted to do the same thing.
I'm curious, when you think about the technology itself, is there one lab that is just really good at developing models that hack well? Or is it you're using a combination of labs? Are there limits of the closed source models and you need to use open
Yeah,
source
who's scraping the dark
sometimes?
web for the repos of
I'm
hacking?
so curious.
Yeah, I mean, all the models are different, and there's lots of great models out there, and so I think it's a vibrant ecosystem, and it's great to build in that.
Are you stuck in distribution in terms of like action? Like, how do you insert creativity? Like, are you just like forcibly post-training these models to get them to be more creative and do things like look at videos that see if there's any credentials on the screen?
That's a great example of kind of how in the age of AI-powered attackers, right? Everything is getting so compressed down. In an ordinary attack, that might not have even been found, right? But AI agents operating on behest of adversaries are going to find everything, right? As soon as you get into an environment, it's going to spread immediately, and an attacker is going to be everywhere. Dwell time is going to go from weeks down to seconds, and it's going to be exhaustive in the attack, just like a proactive agentic approach to proactive security can be. But it's really going to require that you really be locking down everything. To the other part of your question, if you think about what is so important about training models and why it's important to have the best hackers and the best experts, I think it's really a safety question, right? That if you just allow AI to go rampant in an environment, you're going to have a highly destructive outcome. And so one of the biggest things that we focus on is how do you have safe deployment of AI models, particularly for proactive cybersecurity. And so that's one of the biggest things, where it's having human experts who have been doing this for decades in the most sensitive environments in the world, for the most sensitive institutions in the world, and then reinforcing our models to have that expertise, to have that safety. Is it okay to execute this command, yes or no? Is it okay to attempt this technique in this kind of environment? That's really the key piece where that I think is going to be so important to this and to the safe deployment of AI technology in real enterprises. We're seeing this now today, where you can have software engineers that are coaching coding agents as they go through. But as we want those systems to become longer running, to take on more complex tasks, safety really is going to become the most important element.
Actually, maybe this is a nice segue. Like, how do you guys think about the balance between human guidance and like agent autonomy?
Yep.
Like, do you eventually just want to go full, like, turn the dial all the way up on the autonomy side, or how do you guys feel about it?
Yeah, I think ultimately our North Star is that everything can be autonomous, right? That we believe fundamentally that in a few years, all offense in the cyber domain will be conducted autonomously by attackers who have no regard for the safety or knock-on effects that might impact an organization. And so it's going to be critically important that organizations are able to move at autonomous speed too. And so we see it as working towards that future where everything can be autonomous. And then along the way, it's important to be able to train in a safe way with a human in the loop, to deploy systems iteratively with humans in the loop, to have a safe deployment, to have safe adoption of the technology, but ultimately in service of going towards an autonomous future where it's going to be machine versus machine, whether it's controlled by an adversary or controlled by a defender, and really needing to go and be able to meet at the speed of the attack.
To kind of approach the problem today, we know what's safe and what's not. So for example, mapping out an application, kind of spidering out the different pages or things like that, or in an environment, doing initial host discovery, doing initial port scan, identifying what's a database, what's a domain controller, doing LDAP search if you have a standard set of credentials. Some of that stuff is very safe and read-only, and so it's not going to disrupt services per se. But then once you get to like, hey, I found this thing, I want to do remote code execution on that, that's where like, hey, we really need a human in the loop to approve every single action thereafter. So categorizing the level of actions that you do within an attack is it critical to scale, because otherwise you're approving literally thousands of commands, which is just not scalable. So you have to kind of let it go to during the safe parts, that toil, that recon, that initial just a lot of groundwork needs to get done, and then you take a lot of those to build some of these attack paths. Some of that stuff can be automated safely, and some of it won't. And so that's where you really need to add that human in the loop component, where we really do accept commands, or we can redirect it with natural language. Actually, that's not the right way to go. You should do this, and redirect it to a different route if we wanted to, or we just take over. One of those two.
And ultimately, the goal is the same as in the driving domain, right? Where the goal is to decrease the rate of disengagements while improving quality of the overall system.
What's interesting to me is like in the physical realm, we've always known that like physical war is moving toward more of like autonomous drone systems, et cetera. Like I have a friend who facetiously like to say that every future war will just be like a coding competition because there's like, two different nations that are like having their coders, battle out with different drones. Obviously, like from like the commercial entity, the digital realm, like that's going to happen too. We're going to move this like autonomous like warfare. One of the things that comes to mind is like, say you guys are able to infuse kind of this hacker DNA into Armadin and it successfully finds these different vulnerabilities or whatnot. Like, how do you guys deal with both, negating false positives, but also like not having this like, flurry of alerts and like helping them kind of move to the remediation path thereafter? Because there's one thing to like surface these problems and another thing to help them like fix it. Like, how much do you guys want to play into that?
We've kind of approached it as you first need to find the issues and then help people fix them.
Yeah.
Fixing tends to be the long tail just because it kind of becomes tantamount to how safe is your QA process today, right? If you want to make changes in an organization's production environment, whether they be code changes into a system, configuration changes on the network, ultimately you have to be able to deploy those changes safely. And many organizations still rely on manual QA processes today. I think that's a huge opportunity for AI agents to help as well, right? If you have the functional correctness that you want out of a system, then being able to have a autonomous QA system that can codify that, and then as our system wants to make changes to improve your security posture, being able to validate those, and now you can actually move at machine speed in the whole system. As soon as new changes are deployed or even shift left, you're constantly pressure testing them for security correctness and then making changes along the way before they get out into a production environment where they could be exploited by an attacker.
I think the other piece is going to be exploitable risk and business impact. We see a lot of like old gen tech that's just a lot of noise. Here's all these findings, like one, how much of those are validated? So what's high fidelity? What really matters? What really works and what doesn't? And then the second one's gonna be business impact. If we compromise 10 accounts, and of those 10 accounts, one of those accounts were able to access 100 systems, and then the other accounts were only accessing one. What's the business impact, right? So like understanding like what's gonna be the biggest bang for your buck for remediation, and then having a prioritized list of what's going to be the biggest impact for you when it comes to reducing the amount of risk per account, per computer, per vulnerability or misconfiguration, and making sure that we provide that output to our customer. That's also what's nice about been doing this our whole career. Like we know exactly what customers want at the end of the day. And so instead of giving you a list of like 100 different findings, you really want to have that prioritized list of what's going to be the most critical and not based on those two things, exploitable risk and business impact.
And I think this was a huge limitation we saw in many Gen 1 systems or kind of early systems in AI security use cases, right? Which were very high false positive rates. It led to a lot of dissatisfaction. It led to poor outcomes. It was adding more noise to an already overwhelmed security team. I think we saw this in the first wave of software coding agents as well, right? Oftentimes those systems were making recommendations that were unhelpful. It added noise. It didn't make you more productive as an engineer. It really slowed you down, right? And I think now we've seen kind of the new wave of those solutions, just like we're now seeing the new wave of AI security solutions that fundamentally are architected in a way to make use of models, to make use of human-in-the-loop training expertise, to be able to deliver those outcomes, as Evan said, right? Where we're finding issues, we're helping you prioritize and assess their exploitability, the business risk they pose, and delivering to you the high fidelity stream, so to speak, where it's not just this endless stream of alerts or noise into your security personnel. It's giving you the 5 things that you can go and fix today that will improve your environment, or the 5 things that we can identify and help you fix in your environment.
I guess what's interesting about the CodeGen case, even when GitHub Copilot first came out, even if it was making people slower, it just seemed to be kind of this universally loved thing. Or there's so many engineers that immediately, regardless of whether they were actually faster or slower, they loved it.
Yeah.
Whether it's just because we love technology or it's just very magical when it does work. I'm curious how you think about building trust within these enterprises. Like, you just go in, find some vulnerabilities, and then they don't automatically start to trust you. Like, how hard of a process is that? Especially given just all the fear and excitement around our eye. Like, what do you guys do?
Well, I think that trust starts with quality, right? And to your point, right, that's kind of why you can have kind of first generation solutions. But now it's really, the Claude codes, the cursors, the anti-gravities, right? The kind of systems that are providing really high quality results that are gaining lots of traction. And there may other good systems as well. And, many good companies working on those products. But fundamentally, it's about delivering trust via quality, delivering a high quality outcome to a customer where we're delivering something that's actionable, something that's exhaustive, something that, as Evan said, kind of the full attack chain in environment, or showing the reachability into a business outcome that you care about as an enterprise, and being able to give you that full picture of things, not just kind of a limited noisy feed.
And how long would you need for that? Like to just show one, like how fast can you, like just to give
Depends
folks
on the
context
maturity of
the
the environment.
Yeah.
But if I'm talking about like the average customer that I would go up against if
Yeah.
we were to do it with humans today,
Yeah.
imagine with AI. I'm telling you, like it's crazy faster. I would say a week at the most, maybe even like a couple of days, depending on the maturity level.
And now we'll have agents that do that in minutes.
Yeah, exactly. Yeah.
Yeah, just to help people contextualize like the brave new world we're about to enter.
Yeah.
And
No,
it's wild.
yeah, and exactly like Travis said, like that would be dwindled down to literally minutes, and it would cost you less than a cup of coffee. We would average customer engagement that we would do with human leds about 60 grand, and that's like, you know, the math is.
That's in India, you're saying.
Yeah, and even so that's like standard consulting rates for just the industry in general.
Got it.
It's about a 2-week, 2-person engagement. That's generally, and then about 1 week of reporting. Like that's your like average engagement for consulting. So you cost 60 grand, like literally we can do that with less than a cup of coffee with the amount of token cost that it would cost to do what we've seen our agents do. Wow. So like the economics is just such a significant difference, you know? It's crazy like how quickly and how much faster we can do everything that we need to.
And what that means for organizations is that they're finally able to scale that outcome, right? They're finally able to go from 1% coverage of the red team to 100% coverage of the red team and get to that proactive security outcome that can be much more powerful than the defensive security outcome that they were previously having to rely on.
So technically, like what has been the hardest part to build? Is it getting the agents to work together really well? Is the security research behind it? Like what have you found to be kind of head banging against the wall difficult?
Yeah, I mean, I think there's like many interesting and open problems, right? One is basically this world of how to do context management when we're no longer talking about a single perspective, when we're no longer talking about a human talking to a chatbot, when we're no longer talking about a software engineer talking to a coding agent, but instead a swarm of coordinated agents that are, mapping across an environment in real time, doing reconnaissance, attempting initial access, moving laterally in an environment, exploiting objectives, right? It's being able to build up the shared memory between that whole system so that you have this kind of hive context that understands everything that's happening, that's able to distill relevant bits and able to keep the system moving, that's able to interact well with post-training. And this is really a completely open space in what we're going after, right? It's moving well beyond kind of this stack of messages in many agentic systems to how do you have this coordination of different perspectives, right? It's the equivalent of you have lots of Waymos or autonomous cars on the street, and what happens if they all start working together, if they all start sharing memory, if they can all start coordinating their actions. I think that's just one of the examples. Another is how do you have ultimate retrieval, right? How do you have full context or full knowledge over everything that's happened in the environment from a security perspective? It's possible for an agent to have that. A human can never have that same capability. And so being able to have every asset that we assess, every point that we're looking at in your network, our agents can go and have full recall over all the security incidents that happen on those assets, all of the different vulnerabilities that have been found and discovered in the past, the threat actors that are most relevant to your environment, being able to map in those TTPs and execute those attacks, and ultimately delivering to you this answer of, if you're concerned about a particular style of attack, we can go and execute that for you in a safe way and give you that answer of, hey, you have a new emerging threat that comes out. Am I safe against this, yes or no? This is kind of the combination of multiple things. It's having distributed graph context management. It's having long recall. It's having being able to operate agents at safe scale and bringing all of that together into a system that can then go and take a domain that I think inherently has sparsity in the verifiability of rewards and build that into a system that can operate at enterprise scale with enterprise quality.
Really cool.
I'm curious, relative to either your competitors or other people in the industry, like what is a controversial thing that Armadin believes, or like maybe a contrarian thing that you believe?
I mean, I think we believe that fundamentally our biggest competition are our cyber adversaries, right? That, really at the end of the day, we're in a nation state level competition with China and other adversarial nations who want to come after Western organizations. And it's a race into who can build the best offense and then build the best autonomous defense and then build a better offense and then build a better defense, and just get into a cycle that really hasn't been possible before, where each side is just, constantly getting better and better and iteratively refining itself to be better and better and better.
That totally makes sense. Like when I think of the dangers of maybe prematurely regulating parts of AI, I mean, this is one of the main things that I think of. I think of this, and then I think of all the lives that we might lose if we somehow handicap our AI development and like all this progress that's happening in drug discovery, like losing that. So I do kind of like this. I mean, this is just this rare thing that I believe is going to happen. And if we, for some reason, unfairly disadvantage the United States, it just seems like China and others will pull ahead, especially in this category.
Exactly, and we're the ones who are going to be developing it safely, right? And I think it's more important than ever that the technology be allowed to flourish, because it's going to anyway, but the development needs to happen in a safe and responsible way.
For sure.
Okay, obligatory question. What's your favorite hack story? It can be from recent or 10 years ago. I'm just so curious. You've seen a lot. Are you allowed to talk about some of them, Amanda?
Yeah, I could talk about one that I
You
think,
can keep an anonymous name. I'm so curious.
So we actually did one recently. That was really interesting.
Oh, cool.
We were able to compromise an external web application that was externally exposed to the internet, and we were able to find a SQL injection vulnerability into that environment. And from the SQL injection vulnerability, we were able to access, we got full remote code execution on the backend web server. And that specific web server was actually a part of a DMZ that had some connectivity into a secure environment, but it was fairly limited. So like we get on there, normally when you're on a system, you look for like what other systems can I connect to from there? And you're usually looking for some sort of like administration ports, like RDP, SSH, any sort of SQL, whether it be MySQL, MySQL, and everything was closed off. But there was this one port that was open, and I was doing some research. It was part of this protocol called AMQS. It's like an IBM QS, like messaging queue service. That's like a known protocol online. And doing some research into it, it's a messaging queue from like back in the day. So I'm like, this looks interesting, but how do I interact with it? And doing more research, it's like a protocol with very well documented, and you can craft, code to interact with it. And so luckily, like the web application itself had libraries that were already compiled in Java that you can leverage the libraries to honestly build a custom client to interact with the messaging queue service. And there's no authentication because it was built like in the 90s where like security wasn't really a thing. And so like it's just not part of the protocol. And so like I vibe coded this really cool client and leveraged the existing libraries that were on their web server because the web application had to use those Java libraries. And so I leveraged those libraries, and then we were able to build the client, interact with the messaging queue. And the messaging queue was critical because it was all like air traffic control messages that were being sent to airliners, and customs whenever like an airliner was coming in and had to put a manifest, like submit a manifest to an EAPIS, which is like required for any sort of inbound airports for multiple countries. And so, we were able to read and write to it, so we can manipulate manifests that were sent. We could read them. That included passport information, like date of birth, everything. You could track like certain people if you knew where to look for, where like in certain countries and stuff like that. So it was kind of a crazy scale, like how much we were able to get from just that one external SQL injection. And so sometimes just when you think like, there's nothing here, like if you take a step further, like that's a really good example of like another one the model can train on, right? Like a unique attack vector that you wouldn't think is an attack. It's just abuse of legitimate service. You know what I mean? Like it's just like that kind of creativity. So that was a really cool, and the impact was major. They had to literally shut down the application externally, even though it was going to cause business impact, because any external threat actor could potentially leverage the same SQL injection vulnerability because it was an unauthenticated SQL injection vulnerability.
Wow.
So it was a big impact. Yeah.
Wow, that's
That
scary.
one was pretty cool. I got many of them.
That one's hard to beat. That was hard
Yeah,
to beat.
that was
That's
pretty cool.
Do you have one, Travis?
Well, we had one recently that was one of our agents that was a computer use agent where we went to the dark web and we got exposed credentials that were on the dark web. We enumerated the external attack surface with the agent of the target. We found 438 credentials that were exposed on the dark web. And then the computer use agent took over and actually used them to log in or attempt to log in. And we found 7 valid accounts, one of which landed us on a 2-factor authentication registration page, which we were then able to register to a phone with permission. And so I think the moral of the story is if you're registering for 2-factor authentication, make sure to complete the process because it's not good unless you've completed the whole thing. So.
Man, I feel like every week at Armadin, the coolest stories are gonna come up. I mean,
so
talk
many.
about good marketing collateral.
I got one more I want to tell you that's pretty cool. So this one engagement we were on, they required us to get access to this like secret network. There was a jump host. The only system that had a route to that environment. We owned the domain, and then we had a route to the jump host, but we had to authenticate to the jump host with a second factor token, which we did not have. But we were able to compromise the RSA server that was actually in Corp, not part of like another domain. And so we had full access to that. And as part of that, so this is actually a really good lesson learned. As part of that, there were seed files, or what they call it, which is a soft token. So like if you have like, you have the RSA hard token, if you have an application, or whether it be on your computer or on your phone, there's a seed file associated with that specific token. We pulled all of them from that entire database, and we luckily were able to find that they had a standard email that every time someone got issued a token, an email would be sent to you, and it would say like, hey, please register your token. The password is like ABC123. And so that same password was for all seed files. So they didn't have a unique password. So like you have the second token, but to actually like import the token into your phone, you have to like actually authenticate to that. And so it was the same password because they wanted to scale onboarding everyone with a soft token. And so like 2 lessons learned there: don't use the same password for every single soft token. And honestly, just don't use soft tokens because there's a seed file associated with each one of them. And so we were able to pull that back, authenticate to it, import the second factor into our phone or any sort of application if you wanted to, and then authenticate to that specific server, and then got access to that environment. So like really cool. There's so many stories, man. Like this.
I keep us posted if there's any, right? I'm terrified to like see the next. I mean, if you talk about predictions for 2026, you gotta imagine that there's some larger scale LLM aided or like totally automated attack on something important.
The hyper attacks.
They know we hear
Yeah.
about it, But yeah, totally.
Yeah, my favorite is the museum heist at the Louvre, where the guys went to the side door and took the crown. It was just so simple and beautiful. that it
Yeah,
worked.
I mean, see, there's just so many attack paths into the Louvre. If you're not mapping all of them,
You guys rock. Thank you so much for being here.
thank you.
really
This
fun.
was wonderful.
I appreciate
Yeah. And congrats on launching Armadin.
Thank you.
Thank you.
Yeah, we're
Thanks, guys.
excited. Absolutely.